All right, Michelle and Abigail, I started and then I forgot to record. So we're just on the first example, and I said that we're just trying to solve for x, and we're looking at 65 as the angle, and x is the adjacent side, and 8 is the hypotenuse side. So we get to use one of the trig functions, SOHCAHTOA. If you need to write that down, go for it. Which one of those are we going to use if we need adjacent and hypotenuse? Yep, cosine. So we do cosine, and cosine of what?
65.
Cosine, we always do the trig function of the angle. So we do cosine of the angle, which is 65, equals, and the adjacent comes first, and the hypotenuse goes below it, so x over 8. And then if we're trying to solve for x,
You multiply the 8.
multiply the 8 over to the other side. So make sure that your calculator's in degrees. Why in degrees? Right, it doesn't screw you up. But why is this problem in degrees?
Because it's
65 is in degrees, right? Okay, so that's why we need to be in the degree units. So on your calculator, just take 8 times cosine of 65. And what do you get?
3.38.
3.38. Does that seem reasonable? Yeah, we knew it was a number between 0 and 8, right? 8 is the hypotenuse, so it can't be any bigger than 8. And it can't be negative, so 3.38. That sounds good.
Did you want to go out 4 or can it be 3?
This one, just do at least 2 decimal places. That's fine. Okay, so 3.38, will that work? Okay, find the measure of angle theta. Now this one is reversed, so pay attention to this one. You might not know how to do this. Angle theta is what we're trying to solve for. Now in this case, I'm given all 3 sides. I'm given 3, 5, and 4. We only need 2 of them. Okay, so pick which sides you want to use.
4 and 3.
4 and 3. Okay, 3 is the
Opposite.
opposite, and 4 is the adjacent. So which trig function uses opposite adjacent? Tangent. TOA, right? Opposite adjacent. So we do tangent, but this time we do tangent of what? What's our angle? X, or they call it theta. Theta is just another name for a variable. They call it x, except theta will always be used in the case of an angle, right? Okay, it's just tangent of an angle equals, and opposite over adjacent would be 3 over 4, right? Now, here's the deal. Watch this real quick. To figure out what angle theta is, the angle theta is trapped inside of tangent, okay? To get it out of there, I can't just divide tangent over, right? That doesn't work because the theta is stuck inside of tangent. So I have to undo the tangent. And when you undo something, it's like finding the inverse. And the inverse of tangent is inverse tangent or arctangent, right? You have a button on your calculator that's tangent to the -1 power, right? That's what it looks like. That's inverse tangent. So inverse tangent and tangent cancel each other out on the left side. So we have theta is equal to inverse tangent of 3 over 4. You see how that works? We do inverse tangent of both sides, and the tangent and inverse tangent cancel each other out. So theta is equal to inverse tangent of 3/4. But if you type that in your calculator, do you guys know how to type that in your calculator? Second tangent of 3/4. That's what that second button is used for.
36.87.
36.87 degrees. Okay. Does that angle look like it probably could be 36.87 degrees? Yeah. Okay. I'm gonna explain this to you because you guys can figure this out, and this is worthwhile to do. Sure.
So I can see that, yeah.
Sure. All of these angles inside of this triangle have to add up to be 180, right?
Yeah.
Okay. This is my 90-degree angle, so these two have to add up to be the other 90. Yeah. Okay. Now I have these 2 angles down here at the bottom. Which one should be larger?
The 5 and 3 in between them.
In between there. Why? It's opposite 4 instead of being opposite 3. Do you see that? Okay, do you see that? Now, if those 2 angles were equal to each other, what would they be? What would they be? They'd be the same. They would both be 45s, right? 45, 45. But since this one has to be larger and this one has to be smaller, we know this one has to be less than 45 and this one has to be greater than 45. Does that make sense? So checking your answer, we were finding the small angle, so we had to have a number that was less than 45, did we? Yeah, right? So kind of checking in your brain, you can see that that's how that kind of works out, right? We found the smaller of the 2 angles, so that has to be less than 45 degrees, right? If you're finding the bigger of the 2 angles, it has to be bigger than 45 degrees. right? Is this making sense? Okay, so that's just kind of a visual check. All right, 3. What are we solving for on 3?
The right triangle.
It says solve the right triangle. When it says that,
Solve it, but it's not that hard.
you solve it, which means solve for everything. All 3 angles, all 3 sides. So even though there's some stuff that's already solved for, I always just label it, okay? So, or I always just write each piece down. A is this side right here. I'm going to make them bigger. B is this side right here. C is 17. You see that? Which angle is angle A?
The one opposite 75.
The 75. Okay, we name angles with capital letters. We name sides with lowercase letters. Okay, which angle is angle B?
Top.
The top. That's the angle theta that they call. And angle C is the 90-degree angle. Okay, so I always just give them names and then I write them off to the side over here. A, B, C, and A, B, C. Okay, we are given 3 of those things already.
The
Yeah.
lowercase c.
We're given lowercase c is 17. Okay, we're given what else?
The
Capital A is 75 and capital C is 90. Those are things that we're given. So even though we're given that, I always just write them down anyway. That way I make sure I have all 6 things at the end. And then we just need to solve for the other one. So B is going to be really easy to solve for. We don't even have to do anything. Right? Okay, so you add those together and subtract from 180, but that's not what Maddie did. Maddie said you could just take 90 and minus 75, right? Rather than add them together and subtract from 180. Does that make sense? This guy should be 17. Or not 17. 15. Bleh, 15 degrees, right? Because those two have to add up to be the other 90. Okay? So don't bother adding them together and subtracting from 180. Just subtract the other one from 90, right? Okay, so that's 15 degrees. Now we just have to find A and B. Which one do you want to find first? A. Okay. Now, which angle do you want to use? Do you want to use 75 or do you want to use, we technically could use 15 at the top. It doesn't matter. Just use 75. Okay, so we're trying to solve for A. And the only other thing that we know for a side is C. So we have to use A and C and 75. Okay, so in relationship to 75, what is A? Opposite. And what's C? The hypotenuse. So which one is opposite hypotenuse? SOH?
We use the degree, the 75.
Yes, yes. You could have used the 15 degree at the top. It doesn't matter. But they just chose to use the 75. Now, if we use the 15 at the top, we would have to use a different trig function. We probably were using cosine instead of sine, right? Okay. But they just said use 75. Whoop, use 75, and then A is the opposite, and C, or the 17, is the hypotenuse. So opposite of hypotenuse, we're going to be using sine. So if we set it up, what are we doing? Sine of?
75.
Sine of 75. The angle goes in there. Equals opposite over hypotenuse. The opposite is A. The hypotenuse is 17. So to find A, multiply by 17. Okay. What is 17 times sine of 75? 14.5. Okay. Now, does that seem appropriate?
I got 16.42. Oh, I did 15.
16.42.
Yeah.
Okay. 16.42. Does that seem appropriate?
Yeah.
Yeah, because it can't be bigger than 17, right? So 16.42 is A. Okay, now, how do we solve for B? There's a couple different things that we can do to solve for B. Now, we could do A squared plus B squared equals C squared, right? Because we have the 2 other sides, but it would probably be better to do another trig function again and just solve for B. So just do the same thing again with 75, but instead use B and 17. Why is that better to do than do the Pythagorean theorem?
Because then you get
More exactly.
Because if we use the Pythagorean theorem, this number, 16.42, we'll have to square that, but we rounded that number, right?
Yeah.
So our C is, or our value for B is going to be even further rounded. So let's go ahead and set up a trig function again. 75, what is B in relationship to 75? Adjacent, and we still have the hypotenuse, right?
Yeah.
For 17. So which one's adjacent hypotenuse?
Cosine.
Cosine of what? 75 equals
B over 17.
B over 17. Okay, multiply by 17. So 17 cosine 75? Something.
4.3999.
Let's go 4.40 if it's 399.
Yeah.
So 4.40 is what that guy is. You guys see why that's better than using the Pythagorean theorem? You're going to be just a little bit further off rounded, if you do the Pythagorean theorem because you would be using our rounded number to get to another number, okay? So you always want to try to avoid that if at all possible, okay? Good? Hold on.
That's what we'll do for the next one, right?
Okay, solve the right triangle in the figure. They have the other things labeled. So you can list them out if you want to, I guess. The 12, the 6, and the 90. Let's just leave those. I'm not going to list all 6 of them out because they don't have them named ABC like we would normally. So we'll just solve for the ones that are missing, okay?
Can you use the 90 degrees or no?
In your sine, cosine, and tangent, no. No, we cannot. Okay, so that's the problem. We don't have an angle here.
Still do the same thing.
And then work backwards.
You can still.
So what do you want to solve first? What do you want to solve first?
Little
It's
a.
like solve theta
A.
with 12 and 6. use
Okay, well,
do
so
the A.
let's do the A first. Caleb wants to use the A. He's really anxious for that. He says use the Pythagorean theorem. So to do A, 6 squared plus
E squared.
A squared, technically is what it's called. But we just put it in the B spot, equals 12 squared. 6 squared is 36 plus A squared equals, what's 12 squared? Can you do that in your head? 144. Okay, then subtract the 36. 108. A squared equals 108. And take the square root of that. It should be like 10 point something.
10.4.
10.4.
10.39. 10.40.
10.40. So the 39 would round up. Okay, 10.40. So that's A, 10.40. Okay, now we want to find an angle. Which angle do you want to find? Theta or beta? That's a B.
Theta.
You want to find theta first? Okay, that's this guy. All right, which two sides are we going to use? Because technically we know A now, 10.40.
So you can do adjacent and hot and
Now, we could do any of them, but which ones are better to use? Why 6 and 12 are better to use?
Nice numbers.
They're nice numbers, but also we rounded this, right? So if we use 10.4, our theta is going to be even further rounded, right? Okay, so we want to use 6 and 12, and those are which ones? Opposite hypotenuse, opposite hypotenuse. That's going to be sine, right? SOH. So sine of what? Sine of theta, that goes in that spot, right? The angle always goes in there, equals opposite over hypotenuse, 6 over 12.
And then you have to do the sine.
Then you do inverse sine. So inverse sine, inverse sine. Theta is equal to inverse sine of 6 over 12, which is 30 degrees. Yeah? Yep, we can. Theta is 30 degrees. Yep. Okay.
Hold on.
Okay. Any questions up to this point? Are we doing okay?
No. Yes.
Other than give you a break to write? So, do we set up the same process again to find beta?
No.
You certainly can if you want.
You
But
can use theta.
we know that this is 90 and then we have 30. So what's the other one have to be?
60.
60, because those have to add up to be the other 90, right? They all add up to only 180. Okay? So that's the kind of nice thing. As soon as we solve one angle, you have the other one figured out. Okay? Are we doing all right?
Yeah.
Lily, are you doing okay? Okay. All right, moving on to the next one. Now we get to the story problems.
This looks gross.
They're not gross. They're really not gross at all.
All right, let's get to example.
These are nice.
6 and
These
we'll
are
move
these
on.
are like the questions that you will have on the ACT. Like, this is this tall and this is this tall. How far is the ladder away from the wall? Like that type of thing. Okay. All right. So they drew you a picture for this one. A straight road leads from an ocean beach at a constant upward angle of 3 degrees. How high above sea level is the road at a point 1 mile from the beach? Okay, so let's see what they've labeled. We have this triangle here. I'm going to make it a little bit more of an angled triangle so we can see it a little bit better. 3 degrees, that's way more than 3 degrees, but I'm just making it so that we can actually label some things. My right angle is here. Why do they label this as 5280?
That's a mile.
That's 1 mile in terms of feet, right? But they want this height in terms of feet, so we can call it h, but they want it in terms of feet, so they switched 1 mile to feet to start with rather than switching it at the end. Okay, happy with that? Anything else that we need to label? Okay, we just need to solve for h, right? The angle that we have, start with the angle always. The angle that we have is 3 degrees. So what is h in relationship to 3?
Opposite.
This is the opposite. 5280 is the
Adjacent.
hypotenuse. So it is adjacent, but the hypotenuse trumps adjacent, right? So opposite hypotenuse, SOH, right? Opposite hypotenuse. So we use sine. Sine of what? 3. The angle goes in there. Equals opposite over hypotenuse. 5280. Okay, then we haven't done any of the hard ones yet. Where the h is on the bottom yet. Do you guys know what to do when the h is on the bottom? We'll get to that. You switch them. Yep. Okay, 5280 times 5280. So sine of 3, 5280. Is this going to be like a big number or a small number? It's opposite 3 degrees. It's opposite 3 degrees. It's going to be like not very big in relationship to 5280, right?
276.33.
276.33 feet.
Yeah, but she wants us to go 2 decimal places.
Yeah. If you do sig figs, that's fine. If you do sig figs, that's fine. But if not, you can give me 2 decimal places. If it doesn't specify, I say at least 2 decimal places. Right. If it doesn't specify, do at least 2 decimal places. Okay. Okay. Now, really in relationship to 5280, that's 276 is a really small number. Why?
Because it's 5,280.
Because it's opposite 3 degrees. This 3 degrees is making it really, really small there, right? Okay, so in relationship to the 5280, that 276 is really small. Okay, that's not very big. All right, moving on. Another story problem. This is the ladder in the wall. According to the safety sticker on a 20-foot ladder, they legit have these. Okay, according to the safety sticker on a 20-foot ladder, the distance from the bottom of the ladder to the base of the wall in which it leans should be 1/4 of the length of the ladder. Okay, so if the ladder is 20 foot, 1/4 of the length of that, what's 1/4 of 20? 5. So we are restricted, and we are only allowed to put this 5 feet away from the wall. They legit have these restrictions. I'll tell you about another restriction here in just a second. That's kind of funny. But a 20-foot ladder, you are restricted, and you have it 5 foot away from the wall. That's all you're allowed to put it away. Okay? What happens if you lean it further away from the wall?
Slide down.
This ladder is going to slide down the wall. Unless you have somebody holding it, right? But assuming that you don't, that ladder is going to slide down the wall. So you'll climb up this ladder right here, and then you're going to go zoop down the wall, and you're going to be laying flat, right? That's what's going to happen. Okay. So 5 foot away from the wall. That's what you're restricted to do. Okay. They want to know how tall or how high up on the wall you can go. Oh wait, how high up on the wall will the ladder reach? So they want us to find h first.
You can just do Pythagoras.
You can do the Pythagorean theorem, okay? Which one is side C?
20.
20 has to be C, so I'm going to put 20 squared over here. Which side do you want A to be? So 5 squared plus h squared, those don't matter what order you put them in. Okay, 25 plus h squared equals 20 squared is 400, right? 2 squared is 4. Then you just put 2 zeros on the end. Now what do? Subtract the 25. H squared equals 375. And then take the square root. 19.36 feet. That's how high up my ladder can touch on the wall. Just to the 19.36 feet mark, right? Okay. B, if the ladder is in this position, what angle does it make with the ground? 19.36 feet. I'm going to label that here. We have to find out what that angle is, okay? We have all 3 sides, but which side do you want to use? The ones we're given, right? Why? Because they're not
more exact.
rounded. They're not rounded, they're more exact. And there's no decimals with them. So that just is a given. We want the adjacent and the hypotenuse. So which one? Cosine. Cosine of what? Theta or x. Well, however you want to label it. I'm not picky about that. Okay. Cosine of theta equals 5 over 20. Now, if you reduce that to 1 over 4, will that be the same? Like if you make it 1 over 4 and then do the inverse cosine? Yeah, it will be fine. Inverse cosine of that? So theta is inverse cosine of 1 over 4 or 5 over 20, however you want to write it. What's that angle going to be? A pretty big angle.
Oops.
What?
75.52.
75.52
Yep.
degrees is the angle there. Okay, one more story quick before we do it. Elevation and depression. We'll have time to do that. Did you know that they restrict ramps, wheelchair ramps? Do we have a wheelchair ramp example? No. Dang it. Wheelchair ramps, okay? You know how a wheelchair ramp is slanted, right?
No.
Okay? Like a ramp going up with the cement that they pour. Okay? The people who pour the cement for the wheelchair ramp, they are restricted in like the angle that they are allowed to do. It can't be like any higher than a whatever degree, right? Okay? So the restriction is they can only go up 1 inch for every 1 foot they go out, right? So every 12 inches that goes the lengthway, they can only go up 1 inch. Okay? So let's say you have a doorway and you need to go, and from here to here is 3 feet, and you need a ramp.
That's gonna be a long ramp.
That's going to be a long ramp. Hey, have you guys seen the ramps where they go one way, go the other way, go the other way, go the other way, right? Why do they do that?
So it's not as long.
So you don't have to walk a half a mile down to get on the ramp to get up to the front of the steps, right? That makes sense? So if you're going up 3 feet, that's 36 inches that you need to go up. So your ramp needs to be 36 foot long. Does that make sense? Okay, now, why do they restrict that? Why do they make it so that you can only go up so high?
So the wheelchair doesn't just like roll backwards.
Because if you have a ramp that's like straight uphill,
They're gonna
that would be a fun ride to let go, right? They would roll all the way back down. Yeah. And you know, some of those ramps, I had to push my grandpa in a wheelchair this last weekend. Some of those ramps, just even as they are, they're hard to push if you have, just up the regulated ramp, you know. I can't imagine having to push him up a steeper ramp.
Hit the weight room.
So there's a reason why they regulate that. What?
Hit the weight room and it won't be a problem.
Sure.
She's got kids to carry.
Kidding me? I'm all muscle here, boy. Look at this. Look at this. So anyway, there's restrictions on all that stuff. Now what happens if, like, I'm opening Perkins and the people that I have pour the cement don't pour the ramp right?
Fire them.
If somebody gets hurt, like wheeling somebody up and down that ramp,
You're gonna get.
I get sued if I don't follow the restrictions, okay? If somebody would get hurt, like the wheelchair would roll back down the ramp, I could get in real huge trouble, okay?
Go to jail.
Good?
like there's a Perkins in my arms.
All right, let's do this last example, and then we'll save the last two for the backside tomorrow, okay?
What are you doing?
All right, so example 7, we have a angles of elevation and angles of depression, okay? They'll use that terminology when they don't give you a picture. Here's what it looks like, okay? I always think about, let's say this is my shoulder right here, okay? Watch this. Here's my shoulder and here's my arm. That's a really long arm. And how many fingers do I have? Do I have 6 fingers? No, 5 fingers. Okay, there's my arm. And if I hold my arm out in front of me, I hold my hand out in front of me, and I say, elevate your arm. What's happening? You're raising it up. So this is an angle of elevation right here, okay? To depress something, not depression, that's like your mood, okay? But if you are depressing something, that means you are putting it down, right? So to depress something, you're looking at an angle of depression that goes that way. So it has to do with the pivot point right here, which would be your shoulder. And if they're saying elevate that or depress that, that's what that looks like, okay? So sometimes they'll say the angle of elevation to the sun, here's my sun right here, okay? And they're saying the angle of elevation to the sun is 20 degrees. That means 20 degrees is down here in that corner. That's the angle of elevation. From the ground to the sun, that angle is going to be 20 degrees, okay? Make sense? That's what elevation depression look like. All right, so indirect measurement. A flagpole casts a 60-foot shadow. Oh, these are like ACT questions all the way right here. These are good because these are easy. Okay, if you know sine, cosine, and tangent. 60 foot is the shadow, and the angle of elevation to the sun is 35 degrees. That's exactly what I said. 35 degrees will be right here. Okay, angle of elevation to the sun. They want to know how tall the flagpole is. So we just decide sine, cosine, or tangent based on the 35. H is the opposite. Oh, they kind of trick you by calling it H, though. You want to say hypotenuse, but it's not. It's the opposite. What is 60? Adjacent. Opposite adjacent, OA is TOA, which is tangent. Tangent of what?
35.
Over
35 equals, they didn't give us a hard one yet. Opposite over adjacent, H over 60.
It's not even that hard.
Well, I know, but they didn't give me, yeah, it's not even that hard. 60 times tangent of 35 you said was what?
42.01.
42.01 feet. Is that where we're in? Flagpole, 42.01 feet. Yes? Good? Okay, I'm going to stop you there. I'm going to go ahead and give you your homework assignment in case you want to start on it. You will have quite a bit of time to work in class tomorrow after we do these two examples. But if you want to get a start on it today, I'll give it to you.